Wanna build an OpenRadioss thermomechanical model from LS-Dyna? Let's make it with a simple Python script. Here we are running our LS-Dyna file .k with our Radioss starter. This is only to see how are the results since the problem is not yet thermomechanically coupled. Check our OpenRadioss videos to see how to run it. Once the starter run, we continue with the engine, that is the solver. For this we include our LS-Dyna file. To reference our LS-Dyna file in our Radioss file, you can put its name after run-command. See my Radioss tutorial repo for this. BTK results. Now that we've finished setting up and running the simulation, let's quickly see how to visualize the results. You use the anim to VTK tool to convert the OpenRadioss animation files into VTK format. This will generate VTK files ready to open in ParaView. If you're new to ParaView, you can find my ParaView tutorials right here on the channel. Once inside ParaView, load the VTK files and to visualize an element erosion, apply a threshold filter. Select the element erosion variable, set the minimum value to 1, and leave the maximum to whatever you need. This will highlight all eroded elements clearly. But wait, you can see the effectively there is not mechanical thermal coupling here, checking the temperature values with a run. Before running your thermomechanical simulation, any changes to the model can be easily done in LS-PrePost. For example, in this case, we modified the contact definition to include only the top elements of the chip as contact segments. This ensures that the interaction with the tool is more accurate during the cutting process. Now in ParaView, we can visualize that change in action. You will see that the tool makes contacts along the entire side of the workpiece, confirming that our updated contact segments are working as intended. Here we are running our custom Python script to convert an LS-Dyna input file into a Radioss-compatible format. It converts the entire model except the materials and the coupling. We manually check our master and slave surfaces to ensure proper contact definitions. Script assigns slave surface segments to node groups by adding 100 to the segment set ID. This works because Radioss allows the slave surface to be defined as a node group. For the master surface, you use a surf definition from part. We've already prepared this chunk of the input file, including both the thermal and the mechanical materials for each part of the model. Later on, the goal is to automate this process entirely. Now, we insert this prepare section into the main model inputs. Just a single merge or paste into the right place. Next, we run the Radioss starter, but this time using model 0000.rad instead of our previous K file. Then we launch our engine 0001.rad, which links to the starter. And there we finally see our simulation running. Elements start deactivating as damage accumulates in the model. We finally can see here that our model is finally thermomechanical coupled and all in native Radioss format. We can tune it in our next video. If you're into FEM, SPH, CFD, remeshing, or just enjoy watching solids get squished by clever math, you're in the right place. I dive into open source solvers, CPU acceleration, and how these methods actually work under the hood. So hit subscribe, or better, hop on the mailing list at opensourcemech.com. No spam, just good stuff. And if you want to support or ask deeper questions, there's always my Patreon. Thanks for watching and happy coding!